Blackjack is a very common game found in casinos all over the world. It's a casino banking game, the most widely played casino banking game in the world according to Wikipedia. And in this video, I'll be running through the code, the flow of code, and the functions and stuff in order to make our own Blackjack game. 239 lines of code, and so let's first run a few games to show you what the output is, and then we'll look at coding this up. So I'm going to run this code here. So Blackjack by L. Swigart, and you can get this code by going to my GitHub link below this video, but the code was written by L. Swigart, and here are the rules of the game. I'll let you read them. If you pause the video, you can read them yourself, but the objective of the game is to get as close to 21 as possible. So Jack, Queen, King are worth 10 points each. The ace is worth either 1 point or 11 points. You can make it, choose what it's worth. But here, I'll just run through a few games first. So how much do I want to bet? So I'm starting with $5,000. Do I want to bet between $1,000 and $5,000? So put in 400 here, and you'll get presented with some cards. And here you can see that I'm on 8 plus 7, so I'm on 15, and the dealer's on 5, but I don't know what that card is there. So he could be on as much as 16. So I'm only on 15 points, and I'm trying to get as close to 21 as possible without busting. If I go over 21, I lose my money. If we both have the same number, then it's draw. And if I have closer to 21 than the dealer does, I win. If the dealer has closer to 21 than I do, then the dealer wins. So in this instance, I'm on 15. So I will hit this. So I'll draw another card, and you'll see what hit means up here. Hit, stand, double down, if you wanted to read that. And in this instance, I've lost. So I've drawn a jack. The dealers had also had a jack, and I've gone over 21, so I've busted, and he's only on 15, so the dealer's won. So press enter to continue. And notice that $400 has been subtracted from my $5,000 starting total. So now I can only bet between $1,000 and $4,600. So I'll bet again. Let's bet 500. So an ace and 13. So I can make that either 4, an ace worth 1, a 3 worth 3. So 3 plus 1 is 4. Or I can say that that ace is worth 11 plus 3, which will be 14. So I will, I'll just, for the sake of it, I'm not trying to win, but for the sake of showing you the different stuff you can do in the program, if I double down on this, and I wanted to bet another $200, I can do that too. So the dealer had 17, I got 19, so I'm higher to 20. I'm closer to 21 than the dealer, so I won that one. And now, just for one more time, I'll just bet say $250 here, and well, I've got 20, so I think I'll stand up for that one. I won't draw another card, and I won't bet any more money. I'll just stand up because I think 20 is pretty close to 21, and I think the dealer's going to have a hard time getting it. So the dealer, the dealer is in this situation here. The dealer is likely to keep on drawing cards for himself. So let's see what happens. Yes, so the dealer has drawn another card for himself. So he's trying to get close to 21. So at the moment he's on 11, 13, 17. So my guess is he might draw one more or not. Well, he has drawn another one, but unfortunately he busted. He went over 21. So I'm 20, I'm closer to 21 than he is. He busted, so now I've got $250. So that's how the game works. Now let's switch this code here. We're going to switch this code over to Sublime Text, and start running through the code. So here's the code. First of all, we have a doc string. Blackjack is a classic card game, also known as 21. This version doesn't have splitting or insurance, which is something you could read about on Wikipedia. If you want more info, Wikipedia, Blackjack. You can view this code on my GitHub link below this video. So first, I noticed that the code's importing random and sys modules. So the sys module here, that implies that instead of using while loops to quit the program or to quit something, it's going to use something from the sys module, like an exit from the sys module. So that simplifies the code a little bit more than otherwise you have to be using while loops everywhere. So first up here, I notice that hearts, diamonds, spades and clubs. So now this program uses images drawn with text characters called ASCII art. So that's where you saw the cards appear before. If I print, if I call the character function here and I put in 9829 and I were to print that, we'll get a heart there. So that's what's happening. It's drawing the images from text characters called ASCII art. You can find out more about ASCII art at you could go to inventwithpython.com character map if you'd like, but I could also put another number in here like 8822 and that will print something like that. It's kind of interesting. You can play around with it and you get different stuff being printed out. So this means that that's where it's getting the artwork from, the hearts, diamonds, spades and clubs from ASCII art. And for the backside of the card, so that's the one where you saw the dealer had a card that wasn't flipped up. It's just naming that value. It's labeling that value backside, which makes sense. So we have a main part of the we're defining a main function here. So will pull all the other functions together underneath the main function. So let's have a look at what other functions there are. You have a getBet function with one parameter. You have a getDeck function with no parameters. We have a displayHands function with 3 parameters. And we have the hand value with 1 parameter, and display cards with 1 parameter. We have a move function, getMove function, with 2 parameters, and there that's handling the D, H, and S. It looks like user input commands. So that's dealing with that, and then we're just ending the main function with name equals main, so that somebody else can then use some of these functions or import these functions into their own files. If you're not familiar with the main and main equals name functions, then I won't go into it too much, but here's some notes on it. If you pause the video and read these notes, or go back and watch my project number 1 video, that will help you understand that. But using name, defining main and using name essentially answers the question: is this function or file being run in the main program I'm working on now, or is this function file being imported? And having it there helps other people, yourselves or whatnot, if you wanted to use a function or something like that, you can then do that. So now I will start off analyzing this code by probably looking at not at the main function, but at the first non-main function, which is getBet. Okay, so line 121, I'll start off by looking at the getBet function, which requires one parameter. So where it's going to ask the player how much they want to bet for this round. So the first thing, it's within a while loop, and I notice here that it's the old school string formatting that's being used. So I'll change that to an F string. So let's make that an F string. And okay, so I've just changed that to an F string there, and it's labeling the user input, which for some reason it's going to convert it to uppercase, which is strange. I don't know why he's done that. And then it strips it other side, which makes sense, and then it's labeling user input bet. So with the strip thing, I think that's the one that strips other side. So if I put x equals, put two spaces there, walloper, put a space like that, I think what that does is strip function print x dot strip. Let's see what it does. Yeah, so it'll print it out so there's no spaces. See, there were spaces here, so now there's no spaces down there. And let's confirm that by getting rid of the strip. And yeah, so that's what the strip function does. So that makes sense. I don't know why I would have used the upper one though, because presumably, how much do you want to bet? It's just going to be a number at some point maybe in the code, but at this point it's not a number, it's a string, it's a default. Oh right, yeah, okay, so I see what he's done. Oh right, yeah, so he's converting it to upper because he's asked you to enter quit in uppercase. So if you enter quit, then it'll say thanks for playing, and then the system import will enable us to exit the program. So that's nice and neat. If the bet is not a decimal, so they haven't put in like 5.3 or something like that, then continue. So if the player didn't enter a number, so if they entered something other than 500, then it'll ask again, how much do you want to bet? And it will convert the bet to an integer here at this point. So then it becomes an integer. And if what's it saying here? If 1 is less than or equal to the bet, and that is less than or equal to the maximum bet, right, then return the bet. So the player's entered a valid bet. Because if you're only starting with $5,000, which at some point in this code it will have to set that constraint, and we'll get onto that later. But if you bet something that's more than the capital you have, then this while loop will take it back and ask you again, how much do you want to bet? So otherwise, that this here handles the get bet, the maximum, how much you want to bet. This is what this function handles, and handles it pretty neatly from my point of view. Okay, so next up is the get deck function. The get deck function here has a docstring. The function is supposed to return a list of rank and suit tuples for all 52 cards. Now, the rank means the number of the card, which will range from 2 to 11. So that's what rank means. It's just, I guess if you're familiar with gambling or whatnot, rank might be obvious to you, but it wasn't to me because I'm not a gambler. But rank just means a value that runs from within the range of 2 and 11. So this function is creating a list, and it's calling that list, it's labeling that list a deck. So it's get deck, so that's good naming. We have a for loop here and another for loop within the for loop. So for each suit in tuple, hearts, diamonds, spades and clubs, so these are variables that we've got from the top here. So they're the variables. They've been defined further up towards the top of the code. For each suit in hearts, diamonds, spades and clubs, another for loop, rank each suit in the range 2 to 11. So that means 2 of hearts, 3 of hearts, 4 of hearts, 5 of hearts, 11 of hearts. The same thing with diamonds, spades and clubs. 1 of clubs, 2 of hearts, 3 of clubs, all the way up to 11 of clubs. So for each rank in that range, 2 to 11, you want to append each one to the deck list, and we want to append the suit, which is hearts, diamonds, spades and clubs. After we've appended the rank, which is from 2 to 11, and we want to convert that 2 to 11 to a string, right? So I will break this code down. I'll convert it over to here and break it down and change this code so I can see what it's actually doing. And then it's got 4 rank. For each rank that's either a jack, queen, king or ace, append that rank and the suit to the deck. So this isn't dealing in values yet. It's just returning a list of rank and suit. It's not saying that this is worth 10 and whatnot. It's just making a list of them. Then we're shuffling the deck. So once it's got this list together, it's going to shuffle it so it'll be in random orders, and then return the deck. So I'm going to break down this code. so I can understand what the hell it's doing. So let's paste it over here. Let's make this a bit bigger. Yep, that's a bit bigger, isn't it? Let's make this whole thing a bit bigger. There, I'll make it even bigger. Alright, no, I won't make it that big though. Let's just go back to this one. No, sorry, go back to this big. Okay, so now if I were to print this out now, what happens? All right, so it's not printing out anything. All right, so let's make sense of this. I want to get rid of that, and I'm gonna move everything over. Now there is a quicker way of doing this in Sublime Text, but I'm only an intermediate programmer, so I'll just do it this way for now until I learn how to do that quicker. Right, so there's a list, there's a for statement, so that's going to be 1 over, that's going to be 2 over, that's going to be 1 over, that's going to be indented twice, and that seems right. Now, random.shuffle deck, print the deck. Now let's see what happens if I were to run that. Hearts is not defined, so I need to define hearts, diamonds and spades, which I'll get from the code up here. So that now will help me with that. Run it again. Random is not defined. Alright, so I've got to import the random module here. Random. Alright, now let's see what happens if it works. Okay, so it's worked. So that's what it does. I was right. The code for get deck will produce all this, and it'll do it. If I run it again, it's all going to be random. Alright, that's pretty neat. So that's useful. I can see how that's going to be useful because we can get, it's all in list form, so the 10 is a string, and that's why it's converted it to a string. So the rank, which is started off here as being an integer from 2 to 11, they have stringed it probably so they can print it out later. So that's my guess. We'll find out why they've stringed it later for sure, but for now my guess is it's can be printed out as a string later on and displayed, and each one's in a tuple which can't be changed, and so it's a tuple within a list. Alright, that's cool. Now I'll run it again, get some random numbers. If I were to get rid of this shuffling here and just print it out, it'll print it out in order, and yeah, it prints it out in order. 2 of hearts, 3 of hearts, 4 of hearts, 5 of hearts, 6, 7, 8, 9, 10 of hearts, jack, queen, king, ace, and then it goes to diamonds, then spades, then clubs. Alright, so I can understand this function now. It's returning a list of random ranks and suits for all 52 cards. That's what it's really doing. Return a random list. You can put random in there, may as well, of cards. Alright, so there's that one. Let's move on to the next one. Okay, so next up is the display hands function. This has 3 parameters. show dealer hand, which is used throughout it, and player hand, which is used a little bit as well. So the point of this function, according to the docstring, is to show the players and dealers cards, but hide the dealer's first card if show dealer's hand is false. So in the beginning of this video, you notice that one of the cards was turned up, and that is hiding the number, the suit and rank. So here we have, if show dealer hand is true, print dealer get hand value. Now the get hand value is a function further down in the code that I haven't looked at yet, but I'll look at that later. But if it's true, print dealer get hand value. And then it's also displaying cards, and I think displaying cards is another function further down as well, so we'll look at that a bit later. Else, if show dealer hand is not true, print dealer question mark hide the dealer's first card. So if the game hasn't got to the point where, to the end point in the game where everyone needs to show their hands, including the dealer, if it hasn't got to that point yet, hide the dealer's first card. So to do that, it's pulling display cards, which is a function further down in the code. It's saying to show the backside of the card, which was defined further up here, backside equals backside. And then it's saying plus dealer hand. So dealer hand, is dealer hand a function? Well, dealer hand is dealt further up in the main function here. But at any rate, it's indexing the dealer hand from 1 through to the end of the index. So this should make more sense as I look at the other functions further down. But for now, display hands also shows the player's cards, player get hand value, which is another function further down, display cards, which is further down. So this function display hands is pulling other functions further down in the code, and so that's pretty much what this one's doing. Let's move on to the next one, get hand value. So next up is the get hand value function. Now this was an interesting function for me to look at as an intermediate Python programmer. Now the point of this function is to returns the value of the cards. Now that's all the cards from 2 to 9, 10s and 11s and 1s. Face cards are worth 10, so face cards are Jack, Queen, King and Ace, but in Blackjack, aces are worth 11 points or 1 point on the way to trying to get as close to or equal to 21. Now this particular function, it picks the most suitable ace value, given that getting close to or equal to 21 is the objective. So that's fairly straightforward for it to pick whichever one, 11 or 1 is closer, it'll pick that. Now, the reason I found this function interesting to analyze is, well, let's just start analyzing it, and then when I get to that point, I'll show you why it was interesting. So we have two variables, value and number of aces, and those variables are assigned the number 0, so indicating that we're starting at 0 points. So we need to add the value for the non-ace cards, and then this function will add the value for the aces, and it'll add it all up and return a final value. For each card in cards, now cards is the only parameter of the getHand value function. So I'll just move on here. Rank equals card and the index of that card. So when I look at this code, how does the program know to add 2 and 5 together? How does it know to add 8 and 9 together? So I'll explain that shortly. But first, let's keep on running with it. If the rank, right, so if it equals an A, then here we have a augmented assignment operator. So now we're starting to use augmented assignment operators. So if the rank is an A, the number of aces, which starts at 0, if it's an A, assign 1 to the number of aces. Now if 2 aces show up in my hand or the dealer's hand, that'll be 1 plus 1, which will mean that number of aces equal 2, because this part here is an augmented assignment operator, and the way they work is A equals 10, B equals 2.3, A plus B equals 12.3. And the reason you have the equals here is it assigns 12.3 to A. So A is no longer going to be worth 10 points. It's forever going to be worth 12.3. So if I said A plus 10, it won't equal 20. A plus 10 will equal 22.3, because that's what augmented assignment operators do, is they add A and B together, which equals 12.3, and it assigns the result, 12.3, to A. So A, going on later on in the code, will no longer equal 10. A will always equal 12.3, unless changed later on further down in the code somehow. So that's what this is doing here. It's saying you got 1 ace, 2 aces, or even 3 aces. Else, if the rank is a K, a king, a queen, or a jack, then that's a face card and make it worth 10 points. So do the same thing and start at 0 And if you've got a king, make it 10. If you've got 2 kings or a king and a queen, the value will equal 20, and so on. Else, if the value is not an A or a king, queen, and jack, if it's a 2, 3, 4, 5, 6, 7, 8, 9, or a 10, make sure it's an integer, convert it to an integer. Alright, now this is where I was confused. I was like, well, it's dealing with aces here, I get that much. You're dealing with aces, you're dealing with tens, but how does the program know how to add 2 and 3 together? That's still not done here. How does it know which ones to add together? Because in the beginning of the code, when I showed you the gameplay, it was said that, you know, I'm currently sitting on 17, or I'm currently sitting on 18, or I've got 20. So it somehow has to add them up, right? I'll explain that to you shortly, but just before I do, let's go on to how the program adds the value for the aces. It's doing the same thing here, an augmented assignment operator, and it's getting the number of aces. So first of all, it's found out if you've got 1 ace or 2 aces or 3 aces or whatnot, and then it's assigned that to the value, right? And for each iteration in the range number of aces, so it can't be any more than 3 because that'd be 30 points, then if another 10 can be added without busting, do so. So if the value plus 10 is less than or equal to 21, then add 10 to the value and reassign the new total to value, and then return the value. So how does this deals with aces and kings? It doesn't deal with 2s, 3s, 4, 5, 6, 7, 8s, 9s. Where do those codes come? Where do those numbers come from? Well, cards, right? That's a parameter, which means that something has to go inside there when get hands value is called. So let's scroll up, because there's nothing down here with get hands value, so it must be further up the code somewhere where that parameter is being filled in for get hand value to work. So it's not going to be in display hands. We're not going to see 2 plus 5 or whatever. We're not going to see that happen in get value hands. In display hands. Let's scroll up. And what I found was the way it knows it is that you can see how get hand value has the parameter for its cards get player hand and get dealer hand for the dealer one. So get player hand, let's see where that goes. So get player hand, let's scroll all the way up. We can see it being worked up. It's being used up here. Now the first time player hand and dealer hand is used is here. So this is where we need to go to know how it's getting 2, 3, 4, 5 and adding them together. So it's actually popping out the number, whatever number that is, that's randomly shuffled from the deck. And deck has been assigned to get deck. And get deck, we've already talked about get deck. Get deck is a function down here that doesn't have a parameter in it. And get deck is what we've done before. Get deck does this. It splits out this in random order. Now, it does do it random, but I showed you earlier I deleted the random part here, but this comes out in random order, right? So it's getting it from that, and that gives you the range of cards from 2 to 11, Jack, Queen, King, Ace. But really, I was most interested in how it got cards 2 to 10 and then how it added them together. Well, it gets them from the deck. And so when I go down here to the function we're talking about, you can see that it all ties in, and it's getting its card is calling one of these. That's what it's doing. It's getting one of these, and it's saying, okay, you got an 8 and a 5, that's 13. That's what card is doing, because it's all linked into this parameter, which belongs to that function, which is filled in by player hand or dealer hand, which first starts dealing with that here in the deck, and the deck points towards the get deck function, which provides the program with values 2 to 11. So hopefully that makes sense to you, and that's a pretty neat function, this one. It does indeed return the value of the cards, and it does that by also automating whether or not the aces should be worth 11 or 1 relative to it, the total value being equal to or less than 21. So next up is the display cards function, which has cards as a parameter. The purpose of this function is to display all the cards in the cards list. So actually it's going to display them in an ASCII graphical format. Now, when I saw this code, the first thing I noticed was cards, which has been used as a parameter for get hand value, which we previously looked at. So I was just curious to see where that parameter cards is filled in. So what is providing that parameter for display cards? So let's go up in the code and see where display cards is first called or first used. And you'll find that the first time display cards is used is in the display hands function. And so display cards, this is the first time it's used. Its parameter is dealer hand. It's also got display cards player hand in here as well. And we know what player hand and dealer hand, where they come from. We previously looked at that. It comes from popping out the deck, right? So dealer hand and player hand go to the deck and they pop out, and the default for the pop function or the pop method is to take the last item in a list, and that's what the default for pop is. And because we randomly shuffle the deck, it assures us that when we pop out the last item, it's going to be a random item each game. So let's scroll down and now look at display cards a little bit closer. Rows is a value or an object. Rows is a list, and that list deals with the text to display on each row. I'll just get rid of a few things, and I noticed that we have 5 strings here, so there's 5 spaces. So for each iteration and card in cards, so cards is going to be a parameter that's filled in via the randomly shuffled deck, which I talked about over here. So cards down here, that is going to come from here, from that deck, which I said that when we run the deck, it produces random cards. Now I'll just clear that up and shuffle the deck, and then as you can see, it's always a randomly shuffled deck, and it's popping out the last card over here, which is always going to be randomly selected. So it's enumerating this, so it's going to say 0. It's going to, for I, it's going to it's going to index this. That's what enumerate does. Enumerate indexes stuff. I think I know I've dealt with that in the last video, but I'll just show again. What does enumerate mean? The enumerate function returns both the index of each item and the value of each item as I leap through a tuple or a list. So that means that if I'm curious now, because I know what it'll do with apple, right? It'll say that 0 is apple, 1 is banana, 2 is cherry. But I'm curious to see what it does with a tuple. So if I copied this, if I copied that and put that in here, right? If I put that in here, close off the list like that, and I ran this, what would it show? How would it index it? Okay, so what it does, here it is here. What it does is it creates an index. It's saying that, yeah, the 0 and that one, that tuple there, that's 0. 1 in diamonds is 1, and 4 and of clubs is 2. So that's good to see there. I will now continue knowing that it's doing that. So it's enumerating it. Rows index 0, and we have an augmented assignment operator here. It's printing out that, which is the top line of the card, right? So let's have a look at that in action. I will play a game. Whoa, that's a bit weird. I will play a game. What's going on here? Right, so I should be able to run this. Oh, I can't open the file. I'll just pause the video and make this work first. Okay, so now I'm back. It's all ready to run here. So I'll run it. I'll put in 200 here, and I notice. So space one. Sorry, a space 1, 2, 3, 4. All right, so there's 5 there, and if I go back to this code, there's 1, 2, 3, 4, 5. There's actually 6 there, but that's all right because it's going over to the next one. That makes sense why there's 6. So there'll be actually another one. Yeah, there'll be another one here. There's actually 6 in this one as well. So 1, 2, 3, 4, 5, 6. Yep, and that means that this one's going to have 6. So 1, 2. No, not going over. So that's 1, 2, 3, 4, 5, 6. Okay, so that explains that. So that's why we get 6. We get the top line of the ASCII of the card there successfully. Print the top line of the card, which it does. If the card equals the backside of the card, so backside has been, we've dealt with that further up. And let's see if it's mentioned anywhere else in the game. Display hands. It's also mentioned in display hands. Well, funnily enough, it's not really mentioned. It's not mentioned in the main code either. So it really is there to assist in the function, in the display hands function. And other than that, it's only used here. So the main point of it is to actually really show this up for the backside of a card, which we have here. So that there comes from here. If card equals backside, print a card's back. And the saying will rows 1, 2, and 3 will be that. So it's printed the top of it. It's printing the side of it. So it's indexing this one. 2 is that one. Sorry, actually, 1 is this one. 2 is that one. 3 is that one. 0 is this one, which is the index 0 will do this. The index 1 will print out that. The index 2, sorry, the index 0, 1, 2. The index 2 will do that one. The index 3 will do 0, 1, 2, 3. We'll do the last, we'll do that. And so we need something to fill in the bottom of the... No, we don't. No, we don't need anything to fill in the bottom. The bottom's already been done like that. Okay, yes, that's how they've done the bottom. That's pretty neat, isn't it? That's kind of interesting. That's a nice little artistic touch there. So yeah, it's just gone like that. So if it's backside, print out that no matter what it is. If it's backside, print out that there. Else, print the card's front. And we have the old string formatting here instead of F strings. We could make that F strings. We might do that in a sec. Print the card's front. So rank suit equals card. And we know where the card comes from. That comes from, well, it comes from up here. So rank suit. Okay, so rank suit equals card. Now again, rows 1, which will be here, 2 and 3. So it's 0, 1, 2, 3. Rows 1, it's gonna have curly braces here, and in that first row, it's going to fill the curly braces with the rank, and we've already dealt with rank and where that comes from before. Rank is from, it ends up coming from the deck. That's where it all ties back into. And L just 2. Now I haven't come across L just 2 yet. I will pause the video and look up what L just, oh no, left just, yeah, so justify it. It's a justification thing, isn't it? Well, instead of looking it up, why don't I try and make something out of that? So x equals let's say that. Let's have a few spaces in there and put that in here. Let's do that. All right. Now, if I say print x dot L just, I wonder what that would do. L just expect at least one argument got 1. So if I put L just 1 in there, what will happen? Has it moved it over? Don't know. L just 6. Can't see what it's doing different. L just 4. Well, whatever that is, it's not that complicated. I could work it out. But I'm not going to do that for now, just because I don't want to have to pause the video. But yeah, it's like some string thing that I'm pretty sure it's a string adjustment thing. So it's the same for rows 2. It's getting the suit, and the suit that comes from here, from the deck that's been randomly shuffled. That's where the suit will come from, and then the final number down the bottom here, whether it's an ace or a 6. Yeah, I think that's what L just is doing. L just is adjusting the it's adjusting it so if there's a 10, it'll get rid of it. Oh, that's what it's doing. Yeah, it's going 1, 2 and adding it to the end, I reckon. It's doing something like that. You know, that's not that complicated, but that's what it's doing. It's formatting it so it does it like that. Then L just 2, yes. So that's rows 3 working out. Then print each row on the screen. For each row in rows, print the row. That's a pretty neat function there. It's well done. That's definitely for me. It's an intermediate level programming thing for me. I think the part that makes it intermediate for me is really not this L just or R just stuff. It's really the part where it gets the cards from and how that links back to the deck function, the deck list further up in the code. So that's that function, display card. Okay, the second last function is the getMove function. Now it has 2 parameters, and what does this function do? It's supposed to ask the player for their move. So their move consists of either hit, stand, or double down. That's what that means. And returns H for hit, S for stand, and D for double down. While true, so there's got to be a way of exiting this loop, this while loop somewhere, and that will come, evidently that comes about via a condition being met. So keep looping until the player enters a correct move. Okay, that's how you exit it. Determine what moves the player can make. So it starts off this code with giving the player with the option to hit and stand, but no option to double down. Now the player can double down on their first move, Okay, so on the first move, I've just put in 23 here. On the first move, it does give me hit, stand, and double down. So this is the first move, and it does give me the double down option here, which we can tell because they'll have exactly 2 cards. Presumably that means because there are exactly 2 cards, and it is the first move, and so it can tell that it's the first move by seeing how many cards we have, and we only have 2 cards, therefore it gives me the option to double down. So if the length of the player hand, so player hand must be dealt with something up here. Yes, dealt up in display hands here, and I suspect it's feather up. Yep, player hand up here, and yes, as I've mentioned previously in this many times before now, the player hand comes from the deck. So again, it all loops back. A lot of this code loops back to the deck. So making a lot of use of that random deck, which is good to see. This is a good intermediate learning experience, this particular coding is for me. So if the length of the player hand equals 2, so it's only fetched it was only fetched 2, I think it does it at the end, doesn't it? The end of the list. So when that's 2, so it pops it out at the end, when that's 2 and money is greater than 0, append double down to the moves list. So it'll add double down to the end, and that's why I see double down printed out here and not just the first 2. So that deals with providing me with the option to double down, and so that means that if I've done more than 2, if there's more than 2 cards, then it won't give me that option, which indeed, if I put down here D and I put in 1, it won't give me another option. Let's just make another one. Yeah, it can get complicated. I'm not going to play the game again, but hopefully you get the drift of that. So now get the player's move. So this move prompt here, what that's doing is it's joining the join method, the join function. The join function moves plus a right arrow. So that's a string, and joined to that string is the moves, which is either hit, stand, or it could be hit, stand, and double down. Then add to the end of this string a right arrow, and I see that here. If I add this and I want to bet $300, say for example, it does give me again the option to double down, and it does add that little right arrow at the end. So that's why I see the right arrow, because it's joining it. So here's the input, the move prompt, which is up here. Convert whatever I put in to uppercase. So that's good, because I don't always put S in like that. I put a small s in like this. So that's good, because although you could do this another way, it's converting it to upper, and it's saying, well, if the move in H or S, because it's already converted to uppercase, return move, right? So return the move, which is H or S. If the move is a D, if that's true, and double down is in the moves, so you can only do it in the first play, in which case this wouldn't work. So that puts a restriction on that. So this deals with it. Return the move again. Player has entered a valid move. So I can see how that makes sense. Hopefully that made sense to you. And now we can see here, just as the last thing here, before I go into the main function, I think I already mentioned this, is just whenever we define a main function, it's good practice. Well, I guess the point of it is to put if name equals main somewhere in the code or at the end of the code. So let's now move on to the main function. Okay, so finally we're on to the main function. The first thing I notice is a printed tuple that explains the rules. Next, we have an integer, 5,000, has been assigned to money. Now, this main loop is all within one while loop, and it's a while true loop. So you check if the player has run out of money. If money is less than or equal to 0, you're broke. Good thing you weren't playing with real money. Thanks for playing. And then exit. So that comes from here. So it's exited the program at that point. Next, let the player enter their bet for this round. Print money. So that's why it says in the first time it will say money 5,000. That's why it says that. Further up here, when you first start it, it will tell you money 5,000. Well, that comes from here. Then it's the first time in this program it's finally calling a function, or maybe it's not the first time. I think another function called another function further down, but we're calling a function here for the first time in the main program, in the main function, and that function is the getBet function. And we've talked about the getBet function. It asks the player how much they want to bet for the round. And the interesting thing about this is getBet has a parameter in there, and at this point it's saying getBet equals 5,000 in the instance, in the first part of the code, the first running of the code, and associates that with a new variable called bet. So it's already set 5,000 as the first bet, it appears. Give the dealer and player 2 cards from the deck each, and we've talked about this quite a lot already. And as I mentioned, it randomly it uses getDeck, which randomly provides the cards, and it associates that with a new variable called deck, and it pops out 2 of the cards and assigns them to dealer hand and assigns 2 cards to the player's hand. Next up, we've got to handle the player's actions. So print bet bet. So that then, what would that be? Well, let's have a look. Press enter to continue. You lost. Press enter to continue. How much do you want to bet? So it says, yeah, money there. How much do you want to bet? 24. All right. So what exactly is? Well, it must be printing out bet, mustn't it? It's as simple as that, really. But I want to get it up here. So, oh, there you go. It's printed out that there. Bet. So my bet is 24. That's weird how that happened. I went from there down to there without me doing it. So that's how that happens. So it's just printing out. It's not printing out 5,000. It's printing out whatever I bet, the quantity that I bet. While true, keep looping until the player stands or busts. So display hands function is being called here, and the parameters are coming from the player hand and the dealer hand, and the last parameter on display hands is false because it's show dealer hand. So as long as that stays false, it'll keep on looping. Well, it's going to keep on looping because there's no need to display the dealer's hand until the game has stopped, until necessary. So until a condition has been met, which you should see a bit later. Check if the player has bust. So if the get hand value is greater than 21, then break this while loop. Get the player's move, either H, S, or D. Move equals get move. So get move function is being called here, and the get move function, we've talked about that already. It deals with hit, stand, and or double down, depending on where one is in the game, if it's the first move or not. And it's saying that the money minus the bet, so 5,000 minus a bet of 300 would be, 4,700, and then the player hand here. So that's the get move function has 2 parameters, player hand and money. So that's where it gets the money parameter from, by subtracting your bet from it. Handle the player's action. If the move equals D, the player is doubling down, they can increase their bet. So here we've got a new variable, and that's asking for the money minus the bet. All right, and it's another get bet thing. So it's called, so additional bet is calling the get bet function. It's applying 2 parameters to that get bet function. The second parameter is money minus bet, and to meet the first, it's getting the minimum from that, it appears here. No, it's money minus bet, and then it's bet. So get bet, where's get bet again? Get move, display cards, get hand, display, get deck, get bet. So actually get bet only has one parameter, so it's providing that parameter in this here. So it's saying bet, bit complicated, this bit is saying bet equals get bet money. Anyway, I'm not going to look too much into this one, but you can look into that one for yourself, because I did work this out before and I'm not going to bother working it out again. But get bet assigned additional bet, an augmented assignment operator for additional bet, So plus the bet plus the additional bet. Assign it again to bet. And so the bet is increased to whatever it's increased at. Print bet. Alright. Well, let's play this game and see. So pick D for double down. How much do you want to bet? So it's only given me 1 to 24, and so I think that's why you had the minimum in there. So it's picking the minimum between. Somehow you're gonna pick the money minus the bet. The bet's always going to be smaller, I think, than money minus bet. So it's going to get the minimum one from there, which is, in this instance here, is 24, because that's how the blackjack rules work. You can't bet more than your first bet amount. So print the bet. How much do you want to bet? 15. Alright, so 15, bet increased to 39. Bet increased to 39. Bet 39. Bet 39. If the move, which is get move, which is already called the get move function, is an H or a D, then a new card will be drawn from the end, so down here somewhere, from whatever the end was. Rank and suit equals the new card. You drew a format string with the rank and the suit, and rank and suit comes from the deck, which we've already talked about a lot. The player hand will have appended to it the new card. If the get hand value, so the get hand value here, cards, if that returns the value of the cards, face cards worth 10, so that calculates the value of the cards. If the value of the cards is greater than 21, the player is busted and continue, because it's going to continue because it wants to show you what the dealer had. If move in, or go on to the next round or whatever, if the move is S or D, standard doubling down stops the player's turn, because we've already done it. D up here. And S is standing, so that does stop the player's turn. Handle the dealer's actions, so get hand value. I'm not going to go too much into this. Show the final hands. Okay, so I'll talk about show the final hands, and that'll finish this video. Display hands, play hand, dealer hand, true. Player hand, get hand value, player hand. So get hand value has the player's hand, and then get hand value, which links up to the deck again, and the final calculations of everything, they're being assigned to new variables finally, and those new variables are just the player's value and the dealer value. So it all comes down to these two variables. If the dealer value is greater than 21, dealer bust, you win, and put the bet in here. Money, augmented assignment operator is adding that value to the money at the top here. And yeah, if the player's value is greater than 21 or the player's value is less than the dealer's value, you lost. Subtract it from the bet. Else, if the player's value is greater than dealer value, you won. And if the player's value is the same as the dealer's value, it's a tie. The bet is returned to you. Press enter, continue, new line. All right, so that was quite a lot of code, 239 lines of code there. And to make, well, I think this is a pretty neat game. So that's the end of this video. Catch you around.